Good evening, class. We are looking at the foundations for college algebra or prerequisites. This is the first part. So the information that hopefully everybody remembers. So a quick recap of what we have learned previously. Starting with number sets. Natural numbers, also known as counting numbers or positive integers, contain the counting numbers 1, 2, 3, 4, and it's represented with capital N. The three dots are called ellipses and indicate that the numbers continue forever in the same pattern. Whole numbers, we basically add 0. So the same as natural numbers, plus 0, meaning 0, 1, 2, 3 to infinity. Integers, whole numbers, and the opposite or negative of every natural number. In other words, same as the whole numbers, and then go to the left side, -1, -2, and so on, represented with the letter I. Rational number. Any real number that can be expressed in the form of A over B, where A and B are integers and B cannot be 0. Examples, terminating decimals like 0.7 and repeating decimals like 2.3 bar. Irrational number. What's an irrational number? Any real number that is not rational. Example, square root of 2, cube root of 4, pi. Pi is an example of a non-terminating, non-repeating decimal. So pi is 3.14159, and it continues indefinitely. And of course, real numbers, the union of the rational and irrational numbers give us a set called the set of real numbers. Absolute value. A given number's distance from 0 on a number line, by definition, distance from 0. Therefore, the absolute value of every real number is either positive or 0. The absolute value of a number n is written as absolute value of n. We use the absolute value sign to line segment. For example, if we are looking at number 5 and -5, they have the same distance from 0. Therefore, absolute value of 5 and absolute value of -5 are identical. They are both equal to 5. Let's review exponents and polynomials. So this is the synopsis of those formulas, starting with 0 exponent for any non-zero real number a, and a number to the power of 0 is equal to 1. So when the base a and the base b are not equal to 0, a to the power of 0 equals 1. That's the 0 exponential rule. A to the power of m times a to the power of n is a to the power of m plus n, called the product rule. A to the power of m to the power of n is a to the power of m times n, called the power rule. And then we have combination of those, variation of those. AB to the power of m is a to the power of m, b to the power of m. A to the power of m, let me just write that. Over a to the power of n is the quotient rule, a to the power of m minus n. Over b to the power of n is a over a to the power of n, b to the power of n, a to the power minus n. These three are really negative exponential rules. A to the power of negative n is 1 over a to the power of n, 1 over a to the power minus m is a to the power of m, and a over b to the power of negative n is the reciprocal, b over a to the power of positive n. In other words, All you have to do, if you have a negative exponent, just move it. If it's down, bring it up, and vice versa. So looking at this number, obviously, 3 to the power of 0 is 1. Minus 4 to the power of 0 is 1. Now this one, it's important to know that the order of operations, we first raise 4 to the power of 0, that gives us 1. This negative sign makes it negative, and that's the key. Y to the power of 4 times y to the power of 7 using the product rule. Add 4 and 7. We get y to the power of 11. Six z to the power of 5 times 9z cubed times 2z squared. Let's put the numbers next to each other, 6 times 9 times 2, and let's put the variables next to each other. So 6 times 9, 54 times 2 is 108, and z to the power of 5, z to the power of 3, z to the power of 2, following the product rule, 5 plus 3 plus 2, that gives us 108 z to the power of 10. Our rules for all positive integers m and n are all real numbers a and b, a to the power of m to the power of n. You just multiply the two numbers, a to the power of m, n. If it's a, b to the power of m, you just raise each one to the power of m. And if it's a over b to the power of m, again, you raise each one to that power. So for example, here, 5 cubed to the power of 2, that means 5 cubed by itself 2 times. That means 5 to the power of 3 times 2, which makes it 5 to the power of 6. Now, again, the power rule, that means you raise each one to the power of 3. So this piece to the power of 3 and this piece to the power of 3. Now, 3 to the power of 4 to the power of 3, that means 3 to the power of 4 times 3. X squared to the power of 3, that means x to the power of 2 times 3. And that makes it 3 to the power of 12, x to the power of 6. Of course, you can evaluate that, but that's not the purpose of this question. 2 to the power of 5 over b to the power of 4 quantity cubed, and of course the denominator can't be 0. That's why we write b is not equal to 0. So each one gets raised to the power of 3. This becomes 2 to the power of 5 times 3 is 15, and this is b to the power of 4 times 3, 12. So these are some properties involving exponents we should be comfortable with, so we can easily move on. A polynomial is a term or a finite sum of terms with only non-negative integer exponents. In other words, natural numbers permitted on the variable. They can be actually whole numbers because a constant, that means the exponent is 0 for the variable. The degree of a term of a polynomial in one variable is the exponent on the variable in that term. The leading term of a polynomial is the term of highest degree. The leading coefficient is the coefficient of the leading term. Like terms are terms with the same variables raised to the same powers. Example, negative 13 x cubed, 4 x cubed, and minus x cubed. Notice they have the same variable and the same exponent. namely x cubed. In this case, the coefficient is negative 13, in this case 4, in this case negative 1. We can combine like terms. Now here's a warm-up example. We want to add them up. And to do so, we can add these two, and these two. Let's put them together. So for example, this one and this one, we say 2 plus 4 times y to the power of 4 and the rest of it. Do you have to take this step? Not necessarily, but just in case. So 2 and 4, this is 6y to the power of 4. This is negative 3, positive 7, makes it positive 4y squared. This is 1y, and this is 6y. They add up to 7y. Now, this is the leading term. 6 is the leading coefficient. Degree is 4. So the leading term, because it's in descending order, the first one, its coefficient is called the leading coefficient, and its degree is the degree that actually makes up the degree of this polynomial, by the way. A polynomial with one term is called a monomial. A binomial is a two-termed polynomial. A trinomial is a three-term polynomial. Using foiling, F-O-I-L, to multiply two binomials, let's look at special products. So here's an example. Find the product here. So we are going to go with F-O-I-L. F stands for the first, so 6m times 4m. So that would be the first. Then outers would be 6m times negative 3. Then inners would be 1 times 4m. And the last would be 1 times negative 3. And it should happen very fast. And we get over here is minus 18m plus 4m. These are the middle terms that can be added. The rest is very straightforward. This is 24m squared minus 14m minus 3. That's why you have to be very comfortable with the foiling so you can return it into a factored format. The reverse process is called factoring. The reverse process of the product. Special products. X plus y squared is x squared plus 2xy plus y squared. X minus y squared is x squared minus 2xy plus y squared. X plus y times x minus y, those are called conjugates. X squared minus y squared. Now, let's look at the concept of a factoring. Again, reminding you of some of the exponential rules that we've seen. Let's get started. And by the way, should mention this one is B. Okay, that's a typo. All right, so what is the first step? GCF. First, factor out any monomial known as a GCF, the greatest common factor. So that's the first. Number two, consider number of terms. Look at the number of terms. How many do we have? For example, if you have four terms, if it's four or more, we have to go by grouping. If it's four, two, and two, until it works out. The first and the second, the first and the third, the first and the last, however it works. If you have three terms, the following possibilities. One is that it's a perfect square. A squared plus 2ab plus b squared is a plus b squared. So, or a squared minus 2ab plus b squared is a minus b squared. So that's done. If it's not a perfect square and you have x squared plus bx plus c, in other words, the coefficient for x squared, a is just 1, okay, then find two factors of c. So cut the c into two factors whose sum equals b. In other words, x plus the first number times x plus the second number. So the key is to cut the c into two factors. What if it's not 1? A is any number but 1. Then we have the first method known as a trial and error. You just have to do it in the same manner with that one, just hoping that A is a prime number and it makes life easy. Or find two factors of AC. It's called the AC product method, whose sum is B. Write these factors as coefficients of two like terms that when combined equal Bx, and then factor by grouping. We will look at an example just to remind you. And of course, there's another method that I will show you in a moment. Or we may have two terms. It cannot be factored unless it's one of the following. A difference of squares, a squared minus b squared is a plus b times a minus b. A sum of cubes, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Or difference of cubes, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And of course, as always, you can check. How do you check it? By multiplying. That's the beauty of math. You can always check your work, and I highly recommend you do that if you have any doubts, everybody. All right, we want a factor here. We notice that there is a common factor, namely y squared. We take it out. Again, you don't have to do this step just for the sake of argument. You notice if you take out y squared, you get 9y cubed, and over here you get 1. So it's simply y squared times 9y cubed plus 1. In this case, you notice you have 1, 2, 3, 4 terms. The very first question, do I have a common factor for all four? The answer is no. Therefore, we are going to move on. We're going to put these two together, and we're going to put these two together. It works fine. If it doesn't, we have to change. In other words, if this doesn't work, then we put these two together. It doesn't work, we put these two together. So right here, remember, the idea is to come up with the same factor. Okay, so right here, m is in common. We can take it out, and in here, 3 is in common. So the first one gives us m times p squared plus 7, and the second one gives us 3 times p squared plus 7. The idea is that to get exactly the same parentheses, the answer would be the parentheses times whatever is left. So p squared plus 7 times, from here, what's left is m, from here, what's left is 3, and you're done. 10x squared plus 80x plus 150. The first step, can I take a common factor? You notice, obviously, the answer is yes. The common factor, or the GCF, is 10. If I take the 10 out, I get x squared plus 8x plus 15. Now, I want two numbers that are factors of 15, such that their sum is B or 8. Again, 15. 1 times 15. 3 times 5. And we don't have any other factors. And I hope you see 1 times 15, when you add them up, you get 16. So it doesn't do it. But 3 and 5, when you add them up, becomes 8. Therefore, 5 and 3 in any order. And again, because A is 1, then order is not important. You can put it in. But what happens when A is not 1? And what I want to do, I want to show you an example of that. 12x to the power of 4 plus 14x cubed minus 6x squared. The very first question is, do we have a GCF? And the answer is yes. Notice between the three, 2x squared is in common. If I take the 2x squared, I get 6x squared plus 7x minus 3. And so I'm going to work on this. This is the one we are going to factor further. So A is 6, B is 7, C is negative 3. So if we want to go with the AC method, okay, again, it can be done by trial and error. 6, you have to go with 1 and 6 and 2 and 3. So in other words, if you want to go with the trial and error, here's how you do it. You say number 6, I can say x and 6x. I can say 2x and 3x. And then number 3 is 1 and 3, one of them negative. So you have to plug in 1 and 3, one of them negative here. 1 and 3, one of them negative here until it works out. Okay, so this is called the trial and error until it works out. But it might be a tad easier to do it by the AC method. So what is the AC method? We want two numbers such that the product is A times C, which is negative 18, and the sum is B, which is 7. So let me erase my work. And I hope you see that, for example, 18 is 1 and 18, 2 and 9. Of course, negative means one of them must be negative. I hope you recognize negative 2 and positive 9. Therefore, the idea is that this number can be cut into pieces in the following manner. Minus 2x and 9x. Which one do you put first makes no difference. It will work either way. In other words, if I put the 9x here and minus 2x here, it doesn't matter. It works. Okay? You can try. So now you have 4 terms, and you are going to do factor by grouping. These two, 2x comes out times 3x minus 1. These two, number 3 comes out 3x minus 1. So 3x minus 1 is in common. What is left is 2x plus 3, and you're done. Okay, I want you to know that. But I want to show you the second method. I want to show you this, actually the third method. This is the method that you don't find it often. Okay, so I'm going to call it Aura's method. So give it a shot. Some people like that better, and that is the following. First of all, make sure you use the proper variable. In other words, if it's x squared, put x. If it's a b squared, put b. If it's z squared, put z. So be careful with that. Then a represents the number here. So a for this example is number 6. So we're going to put it there. Okay. Now you put the a here, you put the a here, you put the a here. Okay. Now, negative 2 and 9, it doesn't matter where you put that because both of them have 6x. But what happens is that the denominator must go away. So notice over here, I can take a factor of 2 out. Over here, I can take a factor of 3 out. And 2 times 3 is 6 cancels out. So what is left is 3x minus 1 times 2x plus 3. Okay, and that's exactly what we had here. Now, I highly recommend you watch this recording again. This might be the fastest way to factor when a is not 1. So the final answer would be we have the 2x squared and then times 3x minus 1 times 2x plus 3. So that's the synopsis of factoring. And we're going to move on with special factoring. So we have a perfect square trinomials, meaning x squared plus 2xy plus y squared is x plus y squared. X squared minus 2xy plus y squared is x minus y squared. And we want to factor this. We notice that this one is a perfect square. And this one is also a perfect square. And so if you multiply these two, you get 20 PQ times 2, you get 40 PQ. So that means negative, of course. So it's 4P squared minus 2 times 4P times 5Q plus 5Q squared. And therefore, the answer is just like this one, 4P minus 5Q quantity squared. So it's very straightforward, everybody. What about this one? You may notice this is 13x quantity squared. This is 4y squared quantity squared. And this is the product of the 2 times 2. In other words, let's rewrite it in this fashion. And it may not be the case, but this happened to be the case. Therefore, it follows the first one. So 13x and 4y squared to the power of 2. So those are perfect square trinomials. We also have difference of squares. X squared minus y squared is x plus y times x minus y. 4m squared minus 9. I hope you notice that this is a perfect square. And so is this one. So this is 2m quantity squared minus 3 squared, which means we can write it in this format. 2m plus 3 times 2m minus 3. It's completely factored out. Difference and sum of cubes. X cubed minus y cubed is x minus y times x squared plus xy plus y squared. X cubed plus y cubed is x plus y times x squared minus xy plus y squared. So if we want to factor x cubed plus 27, we notice this is x to the third, this is 3 to the power of third. So we're going to rewrite it in this fashion. Now, we follow this one, x plus y, so it becomes x plus 3, x squared minus xy, x times 3. That means minus 3x. And then y squared, that means 3 squared. So we are following this one. So, and we change this one to 9, and we are done. Now, one thing I want everybody to pay attention to, this second piece is not a perfect square trinomial. It needs 2, the same thing here. So this is actually a prime polynomial called because it can't be factored. So we don't want to mix them up, everybody. Lowest term of a rational expression, fundamental principle of fractions. AC over BC is A over B. Of course, B can't be 0, C can't be 0. In short, any fraction, you have to put it in its lowest term before you move. For example, we want to simplify this. The only way we can simplify if there is a common factor between the top and the bottom, which requires factoring. And first, I want to start with the bottom because it's easy. You'd see the 5p in common. So 5p times p plus 4. This one, It's really not too bad. This is 2. So you have to go with 2 and 1, which means 2p and p. And the -4, you have to go with 1 times 4, one of them negative, okay? 2 times 2, one of them negative. Now, the reason this can't be, because if we use 2 and 2, this means this was divisible by 2, and it can't be. You see, 2p plus 2, you can factor out the 2. So it has to be 1 and 4. So you can put +1 minus 4, okay, or -1 plus 4, or you put the 4 here, 1 here, one of them negative. You work it out with the trial and error if you want, okay, or with the method. So A is 2, and this is the trial and method. But with the AC method, A is 2, B is 7, C is -4, and AC is 2 times -4, which makes it -8. So we want two numbers, the product is -8. The sum is 7, and I hope you realize you want factors of -8. The factors are 1 and 8, one of them negative, 2 and 4, one of them negative, and I hope you realize it's -1 and +8 because the two have the product of -8 and the sum of 7. So we are going to rewrite this numerator such that the 7p is cut into 2 pieces. Now, these two, we can factor out the p, these two, we can factor out the 4. And so this becomes 2p minus 1 times what is left? P from the first, 4 from the second. You put it there. You drop the common factor of p plus 4. This is the final answer. So a quick recap. Any fraction must be put in its lowest term. When we have polynomials, we try to factor it. The denominator was obvious. It had a GCF, greatest common factor. The numerator, we did the AC method. So this is the one I highly recommend you try with the method that I mentioned. And I'm going to remind you. This is the way it starts, and you can finish it. See, what color do I want to use? Okay. So what is the value of A? Is 2. So you have 2 here, 2 here, 2 here. What is the variable? The variable is not X, everybody. The variable is P. So you put P. I can't emphasize this enough. And now these are the numbers. Okay. And it doesn't matter. You put it here or here and do the math. And I hope you see that this one is 2 times P plus 4. These two cancel each other. And we get 2P minus 1 times P plus 4, the same thing. So this is a method that I believe it makes it a tad easier than any other method for factoring when A is not equal to 1. Multiplying and dividing rational expressions, just as we do with numbers, we do with expressions. A over B times C over D, we multiply across. We multiply the tops, we multiply the bottoms, and we are done. However, if you're dividing, then the second piece C over D will flip over and you multiply. Okay? And so with having said that, let's do this. 2y squared over 9 times 27 over 8y to the power of 5. Now, you can simplify it the way it is, but just in case if you want to cut it into pieces so it becomes obvious. Again, I would just say 2 goes away, 8 becomes 4, 27 and 9, 9 goes away, becomes 3, y squared goes away, this becomes y cubed. But if we were to cut them into pieces, we get the following. 2, and then this is 9 times 3, and this is y squared. And there isn't, we can write 3 times 3 times 3, but we want to write 9 because we see the 9 at the bottom. Okay. And now if you start crossing like 2 and 2, 9 and 9, and y squared, you're left with 3 over 4y cubed. I don't recommend you do that. I think at your level, you should be able to cancel things out right here. So let me quickly show you. So you should be able to say, okay, 2 goes away. This is 4. 9 goes away. This is 3. Let me use a different color. Y squared goes away. And the exponent becomes 3. And that's your final answer. So hopefully everybody can easily see this. It's very straightforward, everybody. Three p squared plus 11p minus 4 over 24p cubed minus 8p squared divided by 9p plus 36 over 24p to the power 4 minus 36p cubed. Reminding you, division becomes a multiplication. Dividend divisor, the divisor, you flip it over. Now, I chose this number because it does involve factoring, okay? And so it makes it much more interesting. The first one obviously remains. The second one flips over such that the bottom comes to the top and the top goes to the bottom. That's the very first step. Flip over the second fraction, the divisor. And now we are going to factor. Now, again, as far as the first step is concerned for this one class, because this is a prime number. So this is 1 and 3. That means P and 3P. It's really not too bad. Just work with. So in other words, trial and error will do the job. Work with -4. That means either 2 and 2, one of them negative, or 4 and 1, one of them negative. How do you check? You have to check the middle term. I'll show you the answer in a moment. And I'll show you the middle term. The bottom is easy. 8p squared is in common. So this gives you 3p minus 1. You look at the top, 24 and 36. 12 is in common, p to the power 4p cubed. 12p cubed is in common, gives you 2p minus 3. And the bottom simply 9 comes out. Now, that's the first one. Again, I want you to see the following. Notice the product of these two, it's minus p. And the product of these two is 12p. The sum of these two must be the middle term, 11p, and it is. Times, as I mentioned, this one, 12p cubed times 2p minus 3. This is 9 times p plus 4. And now I'm going to erase my work. And let's start from the very first one. P plus 4 is in common. Pick something from the top, something from the bottom. Okay, doesn't matter which fraction because they are being multiplied at this point. 3p minus 1, 3p minus 1. Now, we can continue with this 2, but let's rewrite what is left so we don't make it too crazy. So 12p cubed times 2p minus 3 is left. from the top, 9 times 8p squared is left from the bottom. And now we can do this. We say 12 and 8 cancel each other. This becomes 2 times 4. This becomes 3 times 4. Then we're going to continue with the numbers. 3 completely goes away and 9 changes to 3. So just for the numbers, the top has nothing. That means 1. The bottom has 3 times 2 is 6. Then we look at p cubed versus p squared. So p squared completely goes away. P cubed changes to p. So the numerator has no number left. It has p times 2p minus 3. And the bottom has no p's left. 3 times 2 equals 6. That is the final answer.